Hi, today I'm going to be talking about the Chapter 3 Logic Gates unit in the IGCSE Computer Science course. So for this course, you have to know many things, and you need to be able to draw the logic gates, recognize them, and name all the logic gates that you need to know, which are listed here on the slide. On this slide, you'll have to know 6 of them: the NOT, AND, NAND, OR, NOR, and XOR. You don't have to know the XNOR or exclusive NOR yet, because that's not in the syllabus for the computer science unit here. So here, as seen, you have how to draw the logic gate and the name of the logic gate, as well as the truth table. Logic gates make up electrical circuits in computers and other technology, and they have binary inputs, and they take in these binary inputs and as a result produce binary outputs. Many of the logic gates put together make a logic circuit, and I'll be further explaining this in an example on further slides. These logic circuits are made to carry out specific functions, and you can also use these logic circuits to make certain functions in certain technologies such as fridges and microwaves. As seen on this slide, the NOT, AND, NAND, OR, NOR, and XOR gate have different truth tables with the binary input here and the binary output here. So I'm not going to explain each of the truth tables here because it's already quite simply shown on this slide, so you can take a minute and just look at this slide. If you don't understand it, then you will see in the next slide when I do the example what exactly each logic gate will do in a logic circuit. This is another diagram that shows the logic circuits and logic gate names, as well as the symbols and functions and truth tables. These here are the functions, which is a different way basically of writing out the logic gates and how the logic gates are. These are the symbols as shown as the slide before, the name, and the truth table. You don't need to know the buffer logic gate, and you don't need to know the XNOR, as I said before. As well, for the other ones, you have to know all of them. Okay, this is the logic circuits example from the IGCSE book, the course book. And this is activity 3.2, and these are the logic circuits. This is the example I'll be working through. So you have to produce truth tables for each of the following logic circuits. You're advised to split them up into intermediate parts to help eliminate errors. So I'm going to be doing part A, so that you have an idea of how to separate these and put them into truth tables. You can try it out now and do it yourself, or you can check out the next slide that I'm going to be talking about in just a second to show you how exactly to do it. Okay, this is how to solve the example. This is the truth table that I drew, and below you have basically what 2 inputs you have in order to get the answer. So, as seen on the example here, you have 2 inputs, A and B. Therefore, you'll have 4 combinations of 1s and 0s. 1 and 0 here, 0 and 1, 0 and 0, and 1 and 1. Then I labeled P, Q, R, and X. X is already labeled, but it's good to label them because it'll be easier when you are splitting them up, and basically it reduces the errors as already said in the question. As well as that, I labeled each of the logic gates and, or, and another or, and not, in order to make sure that I don't make any further mistakes as well. So in this example, once you put in the inputs for A and B, so all of the possible inputs, you're going to try to work out P, Q, R, and then X. So to work out P, you have to do input A and input B into an AND gate. So input A and input B into an AND gate is 0 for 1 and 0. For 0 and 1 it's 0, for 0 and 0 it's 0, and for 1 and 1 it's 1. Next, you have to work out the Q answer. To do this, you have to do, once again, A and B into the OR gate. So into the OR gate, 1 and 0 is 1, 0 and 1 is 1, 0 and 0 is 0, and 1 and 1 is 1. Next, you'll have to work out the R value. So the R value is the NOT gate. And to get this value, you just put in the Q answer you got. The NOT gate is quite simple actually, because it's basically opposite whatever answer you got. So if you have 1, then it's 0, and if you have 0, it's 1. So 1 and 0, that was the input before. For Q, you got 1, so it's 0, 1, 0, 0, 1, 1, and then 0. Now you have to work out the X value, which is the last value after being through all of the circuit. To get this, you have to do the P and Q values that you worked out into the OR gate. So you have the first value, 0 and 0, so you get 0. 0 and 0 again, you get 0. 0 and 1, you get 1. 1 and 0, you get 1. So your final values are 0, 0, 1, and 1. Thank you very much for listening, and that's all.